The work I'm going to present today is about a collaboration I was making together with the WHO, that means World Health Organization, and it was based on helping them to understand what was happening in the low and middle income countries regarding mental health just before defining all their policies and intervention activities and their development plannings to all those countries regarding mental health. So most of you know what WHO is. This is the reference entity regarding health all over the world. It's the one that is providing the guidelines on health in the different aspects, let's say. And in that case, this is a collaboration with a specific department, that's the Department of Mental Health and Substance Abuse. And the reason for this collaboration was because after many, many years of making intervention activities in low and middle income countries on nutrition and helping vaccination and helping all those healthcare systems to decrease infections, mortality, and all those sort of things, they didn't get the expected impact on reducing the neonatal mortality, right? So after many years, they discovered that the problem was not about nutrition, not about the main cause of this neonatal mortality. It was not that much about nutrition and vaccination and infections and all those, but that the postpartum major depression of a big part of the mummies was having a direct impact on that. So those that knows about mental health knows that major depression has a big symptom, a big effect, that is decreasing of volition, of the capacity of executing the things you are thinking about. So a depressed person is in the bed in the morning, telling himself, I have to wake up, I have to stand up and go to work, and he just stay on the bed and don't do the action. So you can imagine a mommy with a major depression, with a kid of 2 days life, crying and asking for the milk, and she was sitting somewhere saying, I have to wake up and take the kid, and giving the milk, and don't doing it, right? So in a couple of days, those small kids didn't survive anymore. So at that point, WHO realized that mental health is a relevant matter also in underdeveloped countries. When I was a child, I was told that all these mental problems were part of the developed world and not that much of the subdeveloped countries. And at that moment, they decided that they had to take care about mental health as well. So at that point, they were trying to understand what was the starting situation to make the diagnosis of what was done or not on mental health in the different LAMIC countries, just to understand what was required to do, right? And to do that, they were first of all designing a specific instrument that's called the Who Aims questionnaire. That's a questionnaire about 256 variables. This is not big data, okay? That was querying the country about the different domains that are written here. Then we have a second source of information that was not that much data, but knowledge, the know-how of the experts on what was happening in each one of those countries. And then we have some extra synthetic indicators that the technicians from the WHO were building as a composite calculations on the original data that were measuring things on top of which they reason when they are evaluating the countries, right? So this is 3 different kinds of information, 3 different kinds of sources. Not all of this is data. Not all of this is easy to be represented as a columns in a data set. And the main goal was to understand what was happening, to make a diagnosis, and to help those WHO experts to make the decisions and develop the policies on what to do in the different countries. So first problem here was that we have about 1/5 of missing data, as most of the people working with data are used to. So this is not new for people that work in data. This was propagated to all the calculations and all the synthetic indicators. And so the first thing we had to do, was to work on the pre-processing. Then we had to, we decided to provide a typology, so to identify profiles of countries with similar situations regarding the mental health care systems. And finally, we were working very much, someone was talking here about visualization and how to represent the results, to talk to the experts and so on. That's critical on my point of view. As soon as you have stakeholders that are not, have not technical skills and are placed in the higher levels of decisions, they have very few technical skills and they don't want to have technical skills. So it's very, very important how do you present the information to them in order to bridge the gap in between what data is telling you from the technical point of view and this effective decision-making process, right? And that's part of the thing I will talk to you. So first thing we did was to develop a specific method of missing data imputation that we are using from some years ago now, because we had very few time. And as you know, in missing imputation, we have always this trade-off in between the precision of the imputation of the data and the time we need to build that imputation model. So at that moment, we were designing something that was in the middle, and I will give some clues on that. And this is more or less the process, right? This is a classical data science process where you start by identifying which are your inputs. Then you have some issues related to preprocessing. In that case, on the data mining step, we were using a particular kind of clustering that we already developed some years ago, and I will talk about that. Then we spent quite a lot of time on this post-processing, and the result of that was some new knowledge about what is happening in the mental health systems. And that was concreted in three different outcomes. One was to understand which are the dimensions along which this complex system, like a mental health care system, is evolving around. Which were these profiles or these types of mental health systems that appear in the different countries. And a subproduct that was quite useful was a kind of ontology, kind of a new ontology that is describing all these mental health care systems in low and middle income countries with a specific vocabulary that is different from the one the experts were using in the mental health in developed countries. So regarding the pre-processing, I think the most important part was this missing imputation data. And since we had few time, what we decided was to get, first of all, a subset of relevant variables that were quite full, okay? And we were using the experts to impute in an expert-based way those missing data that were very few. And after that, we were using this first full data matrix to make an initial clustering to find profiles of countries, and then to use the local means to impute all the other missing data to this, using these local means, right? So I'm going to go through that method quite quick. You have a publication that describes the method here, and you have the reference in the slides. And the main advantage of that thing is that it has a very good trade-off in between the accuracy of the obtaining missing values estimators and the required time to complete the data set and to get a full data matrix that you can process in the data mining step. So the nice thing here, okay, with the experts we were selecting these core variables that has a small amount of missing data, so they could work manually on the missing data of this subset of data. They were, in that case, we had very, very few missing data. This requires some meetings with the experts. Discussing which were reasonable values for these empty cells in the data set, and this was consensuated estimation. This can be done, of course, if you have a few number of cells that require this kind of treatment. And the very, very interesting thing that outcome from that process is that we discovered that these experts were using basically two mechanisms for imputing those missing data that map on the missing data methods that we normally use on automatic way. One of those is what we called vertical imputation. Vertical imputation was used in the following ways. So the experts were checking on the same variable another country that they knew it behaves in the similar way as the one we are trying to impute, and they were reasoning by analogy, right? So this is more or less, so for example, in China, the rate of other medical doctors was missing. So since they knew this is a very institutional system, they were finding another country with a mental health based on institutional system, and they were using those values to make the estimation, right? And this is more or less what we do when we are using the KNN method for imputing the missing values. We are finding a closest element in my data set, and I am more or less copying or adapting the values of this closest neighbor. No? So this is a parallelism with the KNN imputation method. On the other side, for other countries, they were reasoning in another way. And we were talking about horizontal imputation. In that case, they were using other variables of the same country that can be more or less predictors of the variable that is missing, right? So, and that's what we do with the regression-based imputation methods and expectation maximization and so on. So that was the second part. This was providing, I'm skipping that one. This was providing a full data matrix, and on top of that full data matrix, we were making a clustering using some particular parameters that I will comment afterwards. We were getting our hierarchical tree. Most of you know that hierarchical clustering is quadratic, so it's not directly scalable to big data. In that case, we have small data, and we can do that. When we have to use this kind of methods for big data, we just connect this with a Cure strategy. I don't know if you know the Cure strategy, but it's based on something like a bootstrap method on the hierarchical clustering, and it's scaling the quadratic complexity of building the dendrogram to the big data scenario. So even with big data, we are using this imputation method, right? So in that case, we got a list of clusters, okay. A list of clusters based on those original variables that are more or less basic and with few missing data that the experts were providing. And here you already understand that we have already biased the process towards the knowledge of the expert, right? Because they have been selecting the variables, they have been providing the imputation of the missing data. So expert is having in all our methodologies an important role, and is transferring their knowledge on the problem to the system in many, many different steps of the whole methodology that we use in these kind of problems. In that case, here we had an intermediate step of improving the data quality. So at that point, experts could understand which were the countries that were appearing in wrong clusters, and they could check on the original data. And for example, it was very unexpected that Burundi was classified originally with the cluster with Uruguay, Chile, and Panama. So at that moment, Burundi was the poorest country in the world. Chile was one of the best positioned countries in the LAMIC domain, because it was about shifting to the next developing level. So this was crashing all the ideas, and when we checked, we discovered that Burundi has falsified all data, and he had been providing a lot of very nice rates and indicators and percentages and everything. So this step was, had a side effect that was improving the quality of data and permitted to make some corrections and some things, and we continued with a better data set than we had at the beginning, okay? After that, we could compute the conditional means of all the variables regarding those clusters, and these were the imputation values that we were using for each one of these variables in each one of the clusters when there was a missing value, right? So this is an adaptation of the conditional mean method, imputation method, that is multivariate and permits to use this conditional imputation taking into account the interactions between many different variables before, instead of using only one. So that was working well, and then the second step on pre-processing was about deciding which were the features to be included in the definite profiling step that we were about to follow at the second step. And then we were taking as well all those synthetic indicators that the experts were using to ordinarily evaluate how a mental health system was performing. So this is, again, a way to transfer knowledge, specific domain knowledge, into the problem. So, for example, there is one index that is called a Lund parameter that is a kind of ratio, and this is a nonlinear relationship between two variables that were measured on the original questionnaire. That's a ratio between the external context that a patient has with the mental health care system with regards to the days that he has been spending in the hospital under recovery in a mental health unit, right? For the experts, this is an index that is giving, is scoring the mental health system towards the mental health approach. So it tells to the experts if mental health patients are basically treated under a social inclusion approach and stay at home as much as possible and try to be working with the social workers and get therapies that permits them to follow more or less a normal life, instead of being recluded in mental health hospitals with aggressive therapies and isolation and all these sort of things. So this is more or less the old way of treating the mental health patients. This is more or less the more modern approach. So this is something that you cannot catch from original data, okay? So, but this is something that is very close to the reasoning way in which the experts evaluate what is happening in a system and how they make the diagnosis. So in the pre-processing step, that most of you know that is one of the most longer along any data science projects, whenever you can catch this kind of things and you can build new variables that contain this kind of aggregated concepts that the experts are using to reason about their domain, it is very effective to create the variables that represent these concepts and to include into the analysis, because this makes the final results of the model to be more close to the reasoning system of the experts, and makes easier that the results of the model are easily understandable by the experts and easily used in decision making, right? After that, and so we spend, as usual, about 70% of the total life of the project into pre-processing and these sort of things. And after that, we were moving to building the model. And in that case, since our goal was to understand how were these mental health care systems, we were proposing to build a typology, so we were moving to a clustering algorithm, and we were not using a traditional hierarchical clustering algorithm, but what we called clustering based on rules. Clustering based on rules is a clustering method that is injecting prior knowledge on the problem into the clustering process itself, just to guarantee that the results of the clusters fit well in what is already well known in the problem, right? So this is a semantic bias that we are introducing in the clustering process. In that case, the semantic bias is introduced through a classical knowledge base, and that means that we introduce some rules given by the experts. Of course, in that case, we are only using consensuated knowledge. I mean, this is not about using subjective rules that might change between one expert and the other one. In that case, we had a big set of international delegates of experts that were consensuating or were agreeing in which part of the already consensuated knowledge on the problem could be useful. And they were providing us basically 3 inputs, not that much. So we are very far from the old knowledge expert systems from the 80s, in which you needed a complete definition of the domain based on rules in order to guarantee that the system was reasoning in the correct way. So we are here relaxing the requirement of complete description of the domain. We need not a complete description of the domain, just a partial one. The important thing is that partial description of the knowledge is based on really well-established knowledge, okay? And in that case, there were 3 things that they were expressing and that we were translating in form of rules as in this step of knowledge engineering, let's say, that were basically all those countries that come from the ancient Soviet Union had an old-fashioned approach for the mental health. Okay, so electroshocks therapies and reclusion on hospitals and all this sort of approach of the mental health was very, very much installed in the in the Soviet Union countries. And so when the Soviet Union was disaggregating, those countries were still very much influenced by this kind of approach. Another thing that they were transferring to us is that the most poor American countries had a particular way of treating mental health that's different from the other countries. And the other thing was that small Asian countries also were behaving in a more oriental way, so in a more particular way, okay? So we were using this knowledge. That's not that much to get that knowledge from experts. So when we move to other domains, we still talk to experts and try to get this kind of prior knowledge about any kind of domain. Then we were using the data coming from the instrument and also those synthetic indicators and some other data coming from the World Bank that were describing more the economy of the countries and so on. And we were running the clustering based on rules. And we got a hierarchy of countries that could be cut in a certain place using the appropriate criteria to define the clusters of countries, right? So the clusters of countries were these 7 profiles. Here we have the countries belonging to each one of these profiles. And then we moved to the post-processing step, in which we tried to make these clusters understandable for the experts, for our stakeholders, okay? Every one of you understand that when we have territorial information, it's very visual to get a map. So that was already telling something to the experts, because here you can see that Maghreb is one cluster, Southern Africa is another cluster, Southern America, the very south cone, is another cluster, except from Paraguay, that seems to be more similar to the Central America, and Western Asia has another profile, and so on. So we can see there is some kind of geographical proximity in between the countries belonging to a certain cluster. This is talking about cultural influence on the health approach in general. Even if we didn't introduce into the data set any information about georeference or about the geographical location and anything related with that. But it's not enough, right? So if you are the president of the mental health department of the WHO, and you need to see if you have to build hospitals or to send psychiatrists to this kind of countries, this map is not enough, right? So one thing is to find the model. The model was found at that point, so we knew which were the clusters, which were the countries belonging to each one of the clusters. We have the results of the data mining, data science, of the data mining processing, but this is not supporting decision making, right? So there is a big gap in between you build a predictive model and you let a politician to make something with your predictive model, or not necessarily a politician. The manager of an industry needs something more than the results of the model or the blind prediction to be able to close a production line, to open a new how much? 5 minutes, to open a new site in another way, right? So after that, we were going for some tools that we have been developing along the years based on what we find when we are talking with the experts, that were helping us to make understandable enough the results of the clustering so that the experts can make decisions on top of that. The first one we developed many years ago was the class panel graph. This is a very, very simple idea. That means to put in a single panel the conditional distributions of as much variables as possible with regards to the clusters, right? This permits very easily to identify which are the variables that behave in a particular way in a particular cluster, which is distinct from what happens in other clusters, right? And so with that, we can move because we have the information of many variables in a single page, and we can easily understand which are the local interactions between the variables in a particular cluster. And we can see, oh, these are men, old, and diabetic, and this is a cluster of women, which is young and is obese, or whatever it is. So in here we got information about countries. But when your counterpart is, for example, a chemical engineer, you can show these conditional distributions and you can talk on top of that. When your counterpart is a doctor, he's not interested on histograms, he's not interested in conditional distributions, and it's not so easy to talk on that. So we introduced a further step after that, that was we as the technicians were making the technical reading of that thing and were labeling which are the variables that are significantly high, significantly lower than the general trend. we were moving to something like that. Okay, we were moving to something like that. Then we were asking to experts to give the semantics of the variables, of the interpretation of the variables in a such formal way. This is what we call the thermometer. In that case, we were doing in manual way. Now we have that tool, wait a moment, that tool that permits the experts to use a kind of latent criteria. In that case, the latent criteria was the modernity of the mental health system, okay, or the goodness of the mental health system, and they were providing the graduation where a variable when a variable has high values, is associated to a better situation or a worse one, and on the opposite sense. And then we can catch this information automatically, and we can transfer the polarity, these semantics of the polarity of the variables to the labeling, the technical labeling that we have been making before. So that means that when having significantly high values means the system is better, we are using green. When having significantly high values, the system is worse, we are using red. And then we even go to a more high symbolic abstraction of the problem, and we just forget about the distributions, and that's what we show to the users, right? We get that thing, then we can permute on a color-based distribution. We get that thing. That's what we use with experts to discuss with them, and you need not to be very much technical to understand that this is the cluster with scarcity, total scarcity. They need everything, whereas this is the cluster that is better placed, right? So this is the basis of a further step, that's conceptualization of clusters. Users understand what the cluster means, and that's the clue. Then in that case, we got an outcome, an additional outcome, that was that all those variables could be grouped through three main aspects that were the capacity of the system, the approach, this more hospital-based or mental-based, and how was the policy framework. And this was the basis for building the ontology on which these 7 profiles are described towards a certain particular value of these 3 taxonomies. So now all the mental health systems on the WHO are described through this kind of vocabulary, and of course giving this kind of description makes it very easy that experts could identify what to do in each one of these profiles. So for those profiles that have no resources, investment was required. For those profiles with resources but an old approach, training and helping them to transform to the more social inclusion approach was required, and that was the impact of this data science. So thank you very much.
Thank you very much for the talk, very interesting topic.
Thank you.
My question is about the amount of effort that has been done on relying on experts. Because I saw that in multiple steps you rely on expert-based knowledge. And at the time that you did the experiment, I think it made sense. But do you think if you redo the experiment to train the model, could you actually skip some of the expert-based step?
It's true that working with experts requires to adapt to the timing of experts, right? So, and they are not processing the things at the same velocity, at the same speed that our supercomputers do, right? But our approach, and now if you think, now we are moving very much to this concept of making data science or making data scientists not a single person but a multidisciplinary team that contains the several profiles. So this is more or less an original, an incipient way of doing this. So in my research or in our applications or in our consultancies, we never exclude the expert from the process. So we always have the technical staff together with the representative of the expert domain knowledge in the data scientist working team in order to get all those semantic knowledge acquisition all along the process. That is the single thing that guarantees that you are not doing the wrong things with your data. So many times we get data and we process it without knowing what it is. So that's not an approach for IoT sensor data, for example. Okay, so when we receive IoT, then we process the IoT and we get some indicators from the signals or whatever it is that come to my database, and then we go for next step in which the expert comes inside, right? But ignoring the experts, in our experience, that's about 30 years long, has always the same consequence. That at the end of the process, you send things and they say, it doesn't make sense. We cannot do anything with that, right? When we are talking about supporting decision making, so when you want that the doctors change a treatment or open more beds in a hospital or close a site of an industry somewhere, when you really want to support this kind of decisions, it's very difficult that they trust on what you provide them if the things are not understandable or the interpretation is not part of the processing all along the system.
Yeah, I understand that, but just one additional note on this. So I think, like for example, for feature selection, it could be a joint effort. Like
yeah, no, but that's
because
true.
Because only using expert-based knowledge, it could be subjective, and maybe some features are not.
In that case, you have all those feature selection techniques or dimensionality reduction that can help in a certain moment, and you can even provide results on that before making the final decisions, and they can agree or not on the proposals of the algorithms. But in any case, if you base your feature selection only on the results of a feature selection algorithm, you risk that the important indicators that they use for reasoning are not present in the final data set. And that has a very big damage at the end on the usage of the model. Maybe you have 2% more accuracy on your model, but they are not going to use it. So since we have all these collinearities and all those high-order interactions between the features, it might happen that another combination of features that do not contain the important ones is as well as a predictor as another one, as the one that the experts would like to use. And so only using the technical part do not permit you to discern in between what is useful for them or what is not useful for them. So my approach is to use the combination.
Thank you for the talk. I have a comment, and the first one is the difference between the semantic biased clustering and the full data-driven clustering, in the sense that I see if you apply a full data-driven clustering, you will have the opportunity to generate new hypotheses of work, while with the other one, you are reproducing existing knowledge. And
not exactly.
And where to use one or the other. And
in fact, I was making a big jump in the middle of the presentation because I was not into the details of the clustering based on rules, but the first iteration of the clustering based on rules is the blind clustering without knowledge. Okay, so we see at the first iteration if those blind results fit well or not on the prior knowledge that the expert has been proposing, and then there is a discussion. So they must analyze if these discrepancies are eliciting to them part of the implicit knowledge they have, or they make no sense at all. right? So at that point, we iterate a couple of 3 times to refine this prior knowledge, and we end up to something that might provide a new view as well, because since we are working on hierarchical clustering, well, I have no time to find the slides for that part, but what we do is we evaluate the knowledge. We mark which elements on the data set follow each one of the rules, right? We build local clustering for each one of these subdomains, let's say. And then we super-classify all the remaining elements with the prototypes of those rules representative, let's say. So the result on that can be that 2 of the rules merge together in a single cluster because the expert thought they were very different things, and from the structural point of view they are not that different. Or that one of the concepts they have been describing becomes subdivided in different subclusters, right? So still using that prior knowledge, you can generate new profiles that they didn't thought about. The point is that what you get is consistent with what it has already been proved by the previous science, okay? And if there are inconsistencies, then we can discuss and we can decide if we accept the inconsistencies or we just discard them. That's why we work.
Thank you. The other one is related to the hierarchical clustering.
Yeah.
How do you set up the level at which you stop?
This is a very nice question. In the dendrogram, the vertical axis is a graduated axis that follows the properties of an ultra matrix, and the level of each one of the nodes is related with the heterogeneity of the clustering of the cluster itself, right? So the protocol says that you must find a level in which the discontinuity in between the 2 successive aggregations is as big as possible. And this is mapping with a technical criteria that's to optimize the Kalinski-Harabatz index. And this Kalinski-Harabatz index is something like generalization of the F index from the ANOVA test. That's a kind of ratio between clusters variance divided by the within clusters variance, right? And this makes totally sense because the variance, there is a theorem from the Ben-Zekri from the 76 or something like that, that proves that variances and inercies are directly related with the quantity of information of a data cloud, right? So when you are maximizing the ratio between the between clusters variance and the within clusters variance, you are maximizing the ratio between distinguishability of the clusters and homogeneity of each cluster inside itself. So that's what you are looking for when you are looking for clusters, to get very homogeneous groups of objects which are very different from the other groups, right? That's what you are looking for. So maximization of that ratio, that Kalinski-Harabatz index, identifies which is the best level to maximize this goodness of the cluster, provided that you have to skip the 2 cluster level normally because it's few information provided in